So structure question related to the topic. We'll do some structure questions as we completed topic 3.1. Some of the question are related to other topics as well, but most of the questions are from 3.1 in this exercise. And you can also use screen annotation. I will enable the screen annotation for certain questions. In the first question, a wave passes through a gap in a barrier. So wave is passing through a gap in a barrier. The wavelength of a wave is same magnitude as the width of the gap. So first thing, we'll have a minimum diffraction or maximum diffraction. So we'll have a maximum diffraction. Why? How you identify we'll have a maximum diffraction? Because the wavelength is same as the width. Okay. So when wavelength and gap size are equal, we'll have a maximum diffraction. You can annotate on the screen and take the correct one. Yes. Dispersion is the property of a spreading of a light when it is passing through the different medium. Yes. Dispersion of light is there. So in this case, dispersion, you have not studied, so means option dispersion cannot be there. Okay. So what you're left with diffraction only.
So refraction or diffraction is same?
No, diffraction is when passing through gap or edges near the edges, and refraction is when medium changes. Like example, wave speed changes because of a change in medium. Yeah, shallow, deep, or a light wave traveling. Okay, this one. This is a refraction. Okay, figure 5.1 shows the 6 wavefronts are traveling on the surface of a deep water. The wave is incident on a boundary with a region where the water is shallow. So the wave is traveling from deep to shallow, means when the medium changes, what property we are studying? We are refraction. Okay. Now, if I want to draw the wavefront, how it will look? You can annotate on the screen. You can annotate on the screen. Straight line should be there. So what happened is actually the wave changes the direction as well as the speed in this case when it moves from deep to shallow. 70 because 18 is, I'm also participating. Okay, thank you for this group. So if you want to, in exam, you have to carry a ruler with you and draw the wavefront like this.
So I have a question.
Yes, Umar.
Can we write with a pencil in the exam? Can we draw with a pencil?
Yes, drawing and the graphs are always with pencil. Whenever there's a drawing, the graph is there always with pencil. Okay. So what will the direction of the wave? The direction of the wave will be like this because the wavefront and the direction of wave are perpendicular to each other. The next question, actually we did this. So we did in the last session. I'll just quickly repeat. The depth of a shallow water is now changed. So the speed of a wave in a shallow water was 0.6 meters per second. The speed of a wave in a deep water was 0.8 meters per second. The distance between the successive wavefront in a deep is 1.4. Calculate the wavelength in a shallow. We know that when a refraction happen or occur, the wave does not change the frequency. Frequency of a wave remain constant. So first what we do, we have the speed in a shallow, we have a speed in a deep, and we have a wavelength in a deep as well. So first we'll find the frequency in a deep. So how to work out the frequency? The formula V equals F lambda, which is called a wave equation. V is the speed of the wave. What is the speed of the wave? 0.8 in a deep.
0.6. 0.8.
So 0.6 is in a shallow and 0.8 is in a deep, and the wavelength also given in a deep. Like this is a wavelength in a deep and this is a speed in a deep. And 0.6 is a speed in the shallow. So I'm talking about deep. So we use the formula V equals F lambda. V is the speed, that is 0.8. F is the frequency, which we don't know. And lambda is a wavelength, that is 1.4. 1.4 is multiplied, other side will be divided. But speed is given in meters per second. So what should be the wavelength? The wavelength should be in meters. So it is 1.4 centimeter.
So we will convert it.
We'll convert into meters. So if I divide by 100, so 0.014. So instead of writing 1.4, what I should write? I should write 0.014. If the speed was given in centimeter per second, I don't have to convert the unit. So 0.014 is multiplied, other side it will be
So the answer is
divided.
57.1.
So 0.8 divided by 0.014,
57.
what is the frequency? 57.14. That is the frequency in a deep. But we know that the wave, when it refracts, it does not change the frequency. Only thing happens is the speed and the wavelength changes. So now we'll write the same formula but shallow. So we write the same formula but now for shallow region. So the same V equals F lambda. What is the speed in a shallow? It's 0.6. So we wrote 0.6. Frequency in the shallow, it will be same as frequency in a deep. That is 57.14 and multiply by lambda. Wavelength, so it will be 0.6 divided by 57.14. What's the answer for wavelength?
The answer is 0.01.
0.105.
0.05? 0.0?
0.0105.
So 0.0105 and the unit will be meters. Okay.
Yes, we can wavelength was
Yeah, I can write as 1 exponent 1.0 or I can write as 10 point. Point is here. So 1, 2 and 3. So I can also write 10.5 into 10⁻³ Okay, next question, question 2. Figure 5.1 is a scale diagram of the wavefront of a red light. Figure 5.1 is a scale diagram of a wavefront of a red light approaching a gap in the barrier. You can annotate on the screen how it will look like. Yes, we have to draw the wavefronts.
Oh,
It should be, the center should be around the gap. Both, look, you don't have to draw the molar and premolar tooth. It's
so what is
I will identify the mistakes and I'll tell what should be the right wavelength.
like this?
Yeah, you can use because it's a scale diagram. So scale diagram means like you can use a measurement. Like in exam, you can use your ruler and measure that.
Unless it says scale diagram. It doesn't say that.
No. If it's not to scale, then you cannot use a measurement. Means that yeah, they mention not to scale as well.
So what is scale?
If this is a gap,
Yes.
sorry, this is a wavelength and this is a gap size. So wavelength looks similar to the gap size or longer. So what we'll have a maximum diffraction. We don't draw wavefront like this. I saw one of the students draw like this. This is wrong. Because the distance between the two wavefronts should also be same. So if this was, let's say 2 centimeter. So when I draw the first one and I draw the second one, the distance should also be 2 centimeter. Distance between the second and the third should also be 2 centimeter. Distance between the third and the fourth should also be 2 centimeter. So this is what you have to keep in mind, that it should be same distance. Yes, Anas? You have a
Sir,
question?
as the increases from like the diffracted wavefronts, does it necessarily have to be that the wavefronts have to touch the barrier? Like you're wanting the end of them, the 2
No,
points
no.
of the
No, not really. You can also draw in this manner. You can draw like this. So it's not necessary that you touch the barrier. You can draw in this manner as well. But it looks that it has diffract more or circular. You can draw like this, that's fine. But it's not necessary that it should touch the barrier.
And sir, do we not have to draw a wavefront in the gap?
No need. Because we want to show a pattern when it passes through the barrier. So we don't have to draw wavefront here. Like I don't have to draw any wavefront in this part. I just have to draw wavefront how it will look once it passes through the gap.
Okay, sir, thank you.
Okay. Feel free to ask your question or doubt because it is important that you understand the topic and should like be able to solve the questions by yourself once, because I have already shared this similar exercise as a weekly homework. So the next is figure 5.2 shows the same barrier and the gap. The wave of a blue light approaches. Remember blue light, you will learn this in electromagnetic spectrum, but I'm giving a hint here. We have violet, indigo, blue, green, yellow, orange, and red. So in terms of the wavelength, the red is having the longest wavelength and violet is having the shortest wavelength. Okay. So before we were having a red light, but now the blue light is approaching. What about the wavelength of a blue light? It will be longer or shorter? Shorter. So means the blue light will have a shorter wavelength. So if the blue light is having a shorter wavelength, what kind of pattern we will observe? Maximum or minimum? Minimum. So you can use the screen annotation to represent the minimum diffraction.
On your list.
You and Subhan.
Sir, no.
So that's how we represent a minimum diffraction. So at least in exam, you should draw 3, not so many. Like minimum, you should draw 3, not curved. It should not be curved. So when we draw, just a minute, I will explain how it can be done. So when you're drawing the minimum, showing a minimum diffraction, this is the first. Then this will be the second. And the third. But the distance between the wavefront should not change because like if this is, let's say you took 2 centimeter, this should also be 2 centimeter. Don't change the distance between the wavefront. If you don't have the incident wavefront, and then you can draw any size. Because here you don't have the incident wavefront. They did not show us what is the incident wavefront. So in that case, you can draw any size, any distance between them, but it should be smaller than the gap size because we are showing minimum diffraction. Minimum diffraction when the wavelength is smaller than the gap size. So means if this is, let's say, 2 centimeter, if this was, let's say, 2 centimeters, so I have to draw less than 2 centimeter. So for the best way is draw the vertical lines first. And the distance should be less than this gap size. And just the edges will bend. Is it clear, this one? About the diffraction?
Sir, I have a question.
Yes.
So, what would be the answer if the wave was green?
If wave was
Green light.
if wave was a green light, because you have the order, like we have violet, indigo, blue, green, yellow, orange, and red. So red is having the longest wavelength and violet is having the shortest wavelength. Okay. So the first example we were having red, which was having a longer maximum. Now this example we have a blue. But what if we have a green? So it will diffract more than blue but less than red.
Is there a way we can?
It's a curvature. Like example, if I want to show more diffraction, I have to draw a circle. This is more diffraction.
Like what?
If it is less diffraction, minimum diffraction. Is it clear, Omar?
Yes, clear, sir.
In a diffraction, the wavelength does not change at all. When there's a diffraction, the wavelength is not changing, the wavelength remains the same, only the waves spread out.
There's one question. People think there are where is the violet, the other people see the wave. Violet, the other people see the wave.
Violet is having a higher frequency, shorter wavelength.
We have to take that into account.
Yes. Like drawing the wavefront, like this is the question. On a figure, draw 3 wavefronts of the wave before it reaches the barrier and draw 3 wavefronts after it passes through the gap. So we know that we have here a blue and this was what? Red. The first part of the question, this was red. Okay. So we know red is having a longer wavelength. If I measure by using a ruler, if this wavelength is example 2 centimeter and I want to show blue, it should be more than 2 or less than 2? Less, because the blue is having a higher frequency, shorter wavelength. So blue is having a smaller wavelength.
What's your what?
Yes, but if higher frequency, shorter wavelength, speed remain constant. In a refraction frequency, look, when there's a reflection, there's no change in frequency, no change in wavelength, no change in speed. Only thing happen is a change in direction. When it's a refraction, there's no change in frequency, but the speed and the wavelength changes. When it is diffraction, speed does not change, frequency can change, wavelength can change. Frequency is longer, if a frequency is higher, wavelength will be short, inverse. So here we have to draw 3 wavefronts before and after. It should be less than So the wavelength of these wavefronts should be less than the previous one which was given to scale. And then when we draw the wavefronts passing, we show a minimum diffraction. Okay, clear? This question, which is about the reflection. The question is the wavefronts of a wave is 1.6 centimeter. On a figure, draw direction of the travel of reflected wave and the 3 successive reflected. How it can be done? Because we know when a reflection happens, the angle of incidence should be equal to angle of reflection. So first we'll have a normal here. Normal is always perpendicular 90 degree to the surface. So when we do this, this is a normal. And we measure this angle. What could be this angle? Let's say, example, let's say this is 20. Example. If this is 20, what will the angle of the reflection? That should also be 20. So I should draw a line first, which is showing a reflected wave. So this is representing the reflected wave with the same angle of 20. Then I have to draw the reflected wavefront. What is the wavefront? Should always be perpendicular to the direction of the wave. So this is 1. They can overlap, no problem. If this is 1, the second, because the wavelength is 1.6 centimeter. So after 1.6 centimeter, I have to draw another wavefront. So this is another wavefront. Then after another 1.6, I have to draw another wavefront. Because the distance between the two successive wavefront, what we call the distance, we call that as a length of a wave or wavelength. Is it clear, this one? Anyone having a doubt or a question till this point?
No, sir.
Then next we have so the next we have figure 6.2 shows an identical wave approaching a barrier. Gap is 1.3. And what was the wavelength given? It's a continuation of the question. The wavelength was 1.6. And what is the gap size?
1.3.
1.3. So
It will be the maximum.
the wavelength is 1.6 lambda. And the gap size is 1.3. On a figure, draw the three successive wave crests that passes through a gap. You can annotate on the screen.
Maximum.
The wavelength, no, this is not right.
Because
Why this is not correct? Because if you see the wavelength is 1.6 and the gap is 1.3. So the wavelength is greater than the gap size. This is also not correct. You will not draw, it should be a curve. Why curve? Because as you can clearly see that the wavelength is greater than the gap size. So maximum diffraction. How we represent a maximum diffraction? It should be a curve. So, and this will have the same distance spacing. If this was 1.6 centimeter apart, this should also be 1.6 centimeter apart. So we'll move on to the next question now. So in exam, just draw the circular wave pattern, wavefront, at a distance of 1.6 centimeter from each other. The next is the frequency of the wave is 4 hertz and the wavelength was what? Wavelength is 1.6 centimeter. You can calculate and state the answer of the speed of the wave. In physics, whenever you have a question, like 2-mark question is there, 1 mark is for writing a formula or showing a substitution. So we have the formula V equals F lambda. But the wavelength is given in centimeter. So you have to convert into meter. If the frequency and the wavelength is in centimeter, like frequency is there in hertz and the wavelength is there in centimeter, your final answer will be centimeter per second. Like if 4 multiplied by 1.6, so what is the answer? 6.4. So in that case, if you multiply, this will be 6.4 centimeters per second. But
it's wrong. We will write in meters.
so centimeter per second. Instead of, look, this is not the right way of converting a unit. The reason is that you don't convert the unit at the last. You don't convert the unit at the last, you convert the unit before substituting in the formula. So you have the formula V equals F lambda. V is a speed, F is a frequency, and the lambda was given 1.6 centimeter. So we convert into meter, 0.016. So this will be 0.016. So when we multiply this, what's the answer? So 0.64.
It's 0.046. 6 further.
So 0.064 and the unit will be meters per second. SI unit of the length is meter. That's why you have to use the SI units. If you see a centimeter, write in meter, convert into meter. If you see a time is there in minutes or hours, convert into second. Always use the SI units. So this is a marking scheme. Acceptable is there in centimeter per second as well, okay? But try to make a habit of writing all the answers in SI unit, so you will remember. Okay, next we have a figure 6.1 shows a crest, a plane wavefront approaching a barrier. You can annotate on the screen to complete this. Figure 6.1 shows a crest of a plane water waves approaching a barrier in the gap. On a figure, draw the three crests of a water waves to the right. So if you compare the gap, the wavelength and the gap size, it looks that it is approximately same. Which shows the wave is spreading out. Okay, I think that's enough for drawing. So as I mentioned, just draw three of them. 1, 2, 3.
They were more than 20.
Then on a figure shows the crest of a plane. The next part of the question. Figure 6.2 shows a crest of a plane wave in a deep approaching a region in a shallow. So it is on a figure, draw three crests and direction of the wave travel in a shallow. You can annotate on the screen to complete this. Moving from deep to shallow, what will happen? So it will slightly lag behind because in a shallow it travels slower. And the second, you have to show the direction.
So what is this?
No, I will point out the mistake. That's why the reason why I enable the screen annotation, that so that
These are there.
okay. Now how it can be done neatly? So what we do, we will draw the wave fronts. Look, if it is traveling at the same speed, then the wavefront in a deep and the wavefront in a shallow will travel to the same. But in a shallow, it travels slower, so it will lag behind. But we have to draw three, so this will be another one. Now, what is the direction of the wave? The direction of the wave is perpendicular to the wavefront. So if these are the wavefront, what will the direction of the wave? So the direction of the wave will be like this. Okay. So that is what you had. So direction of a travel of the wave in a shallow, yes, perpendicular to the wavefront. If the wavefront was like this, and I want to show the direction of the wave, it's in this way. If the wavefront has changed the direction, like it slowed down, so what will the direction of the wave? The direction in which the wave travel, it will be like
Sir,
this.
the angle of the refracting
Ray?
wavefront should be same.
No, angle of refracted wavefront is not same as the incident one. It should be different. That's
No,
why
yes,
the direction.
but you have drawn three, but their angle is not same.
Their angle is not same. I try to make them parallel. It should look parallel. Example, when I drew this one, this is one, then I should draw a parallel line to this first one. Then there will be another parallel line to this one. So they all should be parallel to each other. And what is the direction of the wave travel? So the direction of the wave travel like this. Why we will draw the three? Because in the question they specify that they draw the three. In the question they specify three crests. That's why we do three. You will not lose the mark if you draw an extra, but try to read the question that what they ask, try to answer that only. The next we have two ways in which a transverse wave differ from longitudinal. What is the difference between a transverse and longitudinal?
So the first difference is that in a transverse wave, the direction of travel of the
Right
wave
and
is
left.
perpendicular to vibration of particle.
So two ways in which transverse wave differ from longitudinal. So one is the direction. If you for such questions, I advise student to learn the answer. Like example, if they ask define longitudinal, define transverse, or the difference in this file. So see, we can write any two from this. We can say particle in a transverse wave vibrate perpendicular to direction, or we can say particle in a longitudinal wave vibrate parallel to direction. Here perpendicular parallel, or longitudinal wave have compression and rarefaction, and transverse wave have crest and troughs.
This
So
is really
what?
paper. What's rare?
But it is there. So what are the two differences? One is the vibration of the particle. In a transverse, it is perpendicular, longitudinal, it's parallel. Another one, transverse consists of crest and trough, longitudinal consists of compressions and rarefactions.
1005.
The question is it necessary to have a length of the line of the diffracted wave as same as the incident? No, not really. You mean the refracted one. Refracted should be same length, but not for diffracted. So transverse wave have crest and trough, longitudinal does not have crest and trough. State the typical value of a speed of a sound in water. We discussed like speed of a sound in solid. What was in solid? Solid.
5,000.
5,000. But water is a liquid. So what is the speed? 1,500. Explain why sound travel faster in water than in air. So the sound need a medium, and it depends on the density of a medium, because the water is having high density or particles are closer. That's why it travels faster in water as compared to that in air. So these are 4 questions from this topic. We'll take a break for 10 minutes and we'll start again in 10 minutes.
Then you give